So we treat here the numerator and denominator as one entire unit. We're going to multiply by the LCD of every fraction involved. So we need an x squared. We need a y squared. We need an x cubed. Well, we have two of them already, so how many more do we need? Just one more to get a total of 3. And we need a y cubed. Again, we have two of them. How many more do we need? Just one more. So there's our LCD. So the way that you can solve this is write that number over itself. And then you're simply going to work in the numerator by itself. You're going to distribute the LCD through. So when you distribute, the x squared cancels with two of these x's, leaving an x and a y cubed. When you distribute to the second term, the y squared cancels with two of these y's, leaving negative x cubed and then one of the y's. Okay, we can now move to the denominator. We simplified, we converted our fraction from the numerator into just an expression. Okay, now we're going to do the same thing in the denominator. We're going to distribute this LCD factor to each of the fractions involved. So here we get an x cubed, factors or cancels with the x cubed here, leaving 1 times a y cubed. And at the same time, when we distribute through, the y cubes cancel, leaving a 1 times an x cubed. Okay, so the last part of this, once we've now reduced this from a complex fraction into a single fraction, what we can now do is simplify. So we'll follow the steps for simplifying this. So what common factors can we remove from the first pair? An x and a y. And when we remove an xy, we're left with how many y's in our first group? 2 y's minus how many x's in our last group? 2. And so, again, what I'm going to do here is, even though I know I can factor what remains here, I'm going to rewrite these in the order that I prefer them, which is x's before y's. Now you could put it into this form later, but I'm just going to do it before I get any further. So if I wanted to write my x's first in this top factor, what do I need to remove from both terms here? Take out a negative, so I'm going to put that out front. The y squared becomes a negative y squared. The x squared, negative x squared becomes positive. And then in my denominator, I'm just going to reorder those. And then my final step is to go ahead and factor completely. What does the difference of squares factor into? The sum and difference of the terms being squared. And then the sum of cubes is the denominator. The sum of cubes has two factors, a binomial and a trinomial. The binomial is just the sum of those bases being cubed, so x plus y. The trinomial has a first term that's the first term squared. The last term is the second term squared. And the middle term is the opposite of their product. So x times y, change the sign. Okay, and so again, you continue with the steps in simplifying, and that step is to cancel any common factors. So our x plus y's cancel, and we're left with our overall answer of negative xy times x minus y all over x squared minus xy plus y squared. So there's my simplified form. Okay, again, the downfall to this, or the disadvantage of this method, is you don't get to see all the factors get canceled from the denominator. Did we see one set of factors canceled from the denominator? Yeah, so what do we know x can't be based on this? Negative y. And then we have to go back, because we use this second method, we go back and look, are there any other values that we need to restrict in our domain? What can x not be based on this? 0. And then what about this? Y can't be a 0 either. Okay, so you do need to be able to go back and find those domain restrictions when they occur. Okay. The one other thing that I want to do with this problem is I want to just talk through really quickly the first method for solving this. And so if we were using method 1, what's going to happen in this problem? Again, I may run out of space, we'll see. Is you're going to treat the numerator as a single fraction, treat the denominator as a single fraction. So in our numerator, what's our LCD? X squared, y squared. And so if we take 1 times the missing LCD factor from its denominator, y squared, minus the next fraction's numerator, 1 times the missing LCD factor here. Again, I'm going to factor out my negative from this, or to reorder my terms, but I get negative quantity x squared minus y squared all over x squared, y squared. Okay, now I'm going to do the same thing in the denominator. So here when I look at the denominator, what's my LCD for the denominator? Now it's x cubed, y cubed. So I'm going to take 1 times my missing LCD factor, y cubed, plus my next fraction's numerator 1 times the missing LCD factor, x cubed. And so again, I'm going to reorder my terms, but I get x cubed plus y cubed all over x cubed, y cubed. So in method 2, my next step, so that's my 4.3 section. That's my combining fractions section. So now, remember, this is one fraction divided by another, so I'm going to turn it into an invert and multiply question. So here, when I take my original numerator, I'm going to go ahead and factor it while I rewrite it. So x squared minus y squared factors into x plus y, x minus y, all over x squared, y squared. And I'm going to turn it into multiplying by the reciprocal. So here my x cubed, y cubed, which was in the denominator, gets moved up. And then my x cubed plus y cubed, which is the sum of cubes, gets factored and written in the denominator. It becomes x plus y, and the same as what we did over here. X squared minus xy plus y squared. Okay, now, if this is the process that you used, so that was the review from 4.2, multiplying and dividing. So now we're going to simplify the fraction by canceling common factors. So the x plus y's cancel. These x's cancel with 2 of these. These y's cancel with 2 of these. And so what you see is the exact same thing that we got up here, right? Negative xy times x minus y all over x squared minus xy plus y squared. The advantage to this method is you were able to see all the canceled factors, the restricted domain. So here you see x can't equal 0, y can't equal 0, x can't equal negative y. Remember, because you inverted and multiplied this fraction itself, you have to look at the entire thing. There's no factors in that whole fraction that can ever equal 0. So x can't equal 0 and y can't equal 0, which we just identified already. Okay. And so you could use either method. Choose whichever one works for you. Again, method 1 is always going to work. Method 2 will, again, it will always work, but it might be confusing if you have more than just 1 or 2 distinct LCD factors.